Assalamu alaikum. Today we're going to do integration of trigonometric functions using substitution and integration by parts. Okay, let's do this question. It says find integration of 2x cos of x square plus 1 dx. Okay, we can see that the differentiation of this is found here. So this can easily be done with substitution by part. I will start with saying that let u equals to x square plus 1. So du upon dx is going to be 2x. Okay, if I make dx the subject, why are we making dx the subject? Because we have to replace it here. So dx is going to be du upon 2x. Okay, let's write it here. 2x cos of u, and in place of dx, why am I writing u here? Because x square plus 1 is taken as u. In place of dx, I'm going to write du upon 2x. This can simplify. Now I'm left with integrating cos u dot du. Okay, cos of u, integration of cos of u is sine of u. Okay, plus c. And what was sine? U is x square plus 1. So I can write sine of x square plus 1 plus c. This is the final answer to this question. Okay, let's do this one. Okay, if I take sine of x as u, okay, whenever you've got two trigonometric functions, one of which is actually having a power, if you want to use substitution in this case, you should take the one with power as sine, without the power as sine x. Okay, so I will have to choose this one, and this also without the power as u. Okay, so if I take u equals to sine of x, du upon dx is going to be cos of x. So dx, if I make the subject, it will be du upon cos of x. Okay, now in place of cos of x, I'm writing as it is. In place of sine x, I'm going to write u square. In place of dx, I'm going to write du upon cos of x. This and this will cancel out. You're supposed to integrate u square now. Okay, integration of u square is u cube upon 3 plus c. And what was u? U was sine x. So it will be sine cube x upon 3 plus c. This is the answer. You can even write it as 1 upon 3 sine cube x plus c. Okay, moving on to this one. This is cos cube x. Now, for cos cube x, I can take, let's try this. If I take u as cos of x, okay, and du upon dx is going to be negative sine x. So in place of dx, I can write du upon negative sine x. I don't think this is going to solve the issue. I think let's do it with some other way. Cos cube x, I can write it as cos x into cos square x. Okay, cos square x, I can substitute it with sine, because using the first identity, sine square x plus cos square x equals to 1. So cos square x equals to 1 minus sine square x. In place of cos square x, I'm writing 1 minus sine square x. Okay, if I multiply the two, I will get cos x minus cos x into sine x dot dx. Okay, let's start with the integration process. Okay, we can easily integrate cos x, and that will become sine x. This can be done with substitution. Okay, and we've already done this before here. See. Okay, so I've already done it, but I'm teaching you how to go about doing it alongside. So starting with this cos of x, the integration is going to be sine x. Okay, if you want to use this and use substitution here, I told you that take the function without the power as u. So I will take u equals to sine of x. So du upon dx is going to be negative cos x. Okay, so if I make dx a subject from here, it will be du upon negative cos x. Okay, so minus, I can actually separate them first and then I can deal with it. I can separate cos of x dot dx and minus cos x sine square x dot dx. Okay, integration of cos x is sine x, so this is done. Minus, Now in place of sin x I'm going to write u, so cos of x, and in place of sin x I'm going to write u, so it's u square. In place of dx I'm going to write du upon negative cos x. Now cos x and cos x is cancelled, minus and minus will become positive, sin of x plus integration of u square dot du. This will become sin x plus u square is actually u cube upon 3 plus c. What was u? It was sin x, so it will be u cube sin of x plus sin cube x upon 3 plus c. This is the final answer to this question. Okay, moving on to this one. Okay, if I take this as cot of x, the first one, cot is the same as cos of x upon sin of x. Okay, we see that the integration of this is, differentiation is found in the numerator, so we can easily write directly ln sin x, because if we've done questions like this, that where we see the denominator, and if the differentiation of the denominator is found in the numerator, we can write ln sin x directly. You can recognize it plus c. Or if you want to use substitution, in that case I am going to take using substitution here. I am going to take u as sin x, let u equals to sin x. Du upon dx is going to be cos x, so dx is going to be du upon cos x. Now I'm going to write like this. Cos x is actually cos x divided by sin x. Sin x is taken as u dot dx. Dx is the same as du upon cos of x. Okay, this and this is cancelled. You're supposed to integrate this, and we know that the integration of 1 upon u, because if it's u, if you try to put it up in the numerator, it will become u to the power negative 1, and negative 1, when you start integrating, negative 1 plus positive 1 becomes 0. So the only thing here is to use ln here, and we see that the differential or the derivative of this is found in the numerator, so we can just write ln u here, and u was actually sin x, so you can write ln sin x plus c. So either you use substitution or you use the recognition part, that the derivative of the denominator is found in the numerator. That's why you write ln sin x directly. That will also suffice. Okay, moving on to this question. Okay, for this part where I have to find out tan of x, let's do this as well. Okay, I'm supposed to integrate this. I know tan of x is sin x upon cos x, so I can write sin x upon cos x with the boundaries pi by 3 and pi by 6. Okay, so I can see that the differential of cos x is negative sin x, out of which sin x is already there. I need to put a negative here, so as a result I will put a negative here as well. So I can write minus ln cos x plus c. Okay, in this you have to put the boundaries. Because the boundaries are given, I don't have to put c here. I can simply put the boundaries here. I can take out negative as common, and put the boundaries on pi by of pi by 3 and pi by 6 on ln cos x only. Negative outside, ln cos of pi by 3 minus ln cos of pi by 6. Okay, let's solve the bracket. Cos of pi by 3 is half, so ln half minus cos of pi by 6 is root 3 upon 2. So I can write minus ln half plus ln root 3 upon 2. So ln root 3 upon 2, I'm writing it first because it's positive, minus ln half. That means I can use the quotient law, root 3 upon 2 divided by 1 upon 2. 2 and 2 can cancel out. You're left with root 3. Root 3 can also be written as 3 to the power half, which can be written as half ln 3. So either you give this as the answer or this is the answer. Both are correct. Okay, moving on to this question. Integrate the following by using the substitutions given or otherwise. So I'm doing question number for sin x upon 2 minus cos x, and you have to take the substitution as 2 minus cos x. Okay, so u is 2 minus cos x, so du upon dx is going to be uh, sin x, because integration of cos x is negative sin x, so negative and negative becomes positive. Okay, so dx is going to be du upon sin x. Okay, let's write it here. Sin x upon u. In place of dx, I can write du upon sin x. This and this will cancel out, leaving 1 upon u dot du. And one integration of 1 upon u is ln u. Okay, so this u can be replaced by what was u. U was 2 minus cos x. So you can write ln 2 minus cos x plus c. That's the answer. Now I'm doing the last part. The sixth one. Sine of 2x 1 plus cos of 2x. Okay, so I can they've asked us to take u as 1 plus cos 2x. Okay, so if I'm going to differentiate, it will become du upon dx equals to, in differential of cos of 2x is negative sine 2x into 2, so dx is going to be du upon negative 2 sine 2x. Okay, so I'm writing sine of 2x, sine of 2x into u square dot, in place of dx I'm writing du upon negative 2 sine 2x. Okay, sine 2x and sine 2x will cancel out. You're left with minus 1 upon 2. I've taken the constant out. Integration of u square dot du. Now if I'm going to integrate u square, I will get u cube upon 3 minus 1 upon 2 stays in outside only, plus c. So I can give the final answer as minus 1 upon 6 u cube plus 6. Okay. Okay. Moving on to this one, question number 2. Use a suitable substitution to integrate the following. In this question, they have not given us what should we take as u. So if I'm doing this question, I will take u to be x square. Okay, let's do it. The first one. Let u equals to x square. Du upon dx is going to be 2x. So dx is going to be du upon 2x. So let's start with the integration process. Sin 2x sine of u dot d, in place of dx I'm writing du upon 2x. 2x and 2x will cancel out. Integration of sine u dot du. Now integration of sine u is negative cos u dot du. Okay, what was u? It was x square. I can write minus cos x square. This is the final answer. Plus c. Okay, if I want to do the second one, okay, I will take e to the power sin x as u. Achha, I can do this directly also. Whenever you see that you've got a power of e to some power, and the differential of this is available here. Okay, e to the power sin x, and sin x, the differentiation of the power is multiplied here, so you can directly write this as e to the power sin x plus c. Okay, or you use substitution. I do it directly. I would do it directly because I know this technique that with this works with e, especially specifically with e. So if you see that e has a power and the derivative of this is found here. Okay, so the integration of this whole thing is going to be e to the power sin x only. Okay, so I've done it directly, but if you want to use substitution, how will you use the substitution? That's the question. let me just add a page here. Okay, you can write, let u equals to e to the power 7x sin x. Du upon dx is going to be e to the power sin x into cos x. Okay. So dx is going to be du upon cos x e to the power sin x. So I'm writing integration of cos x e to the power sin x is u dot, in place of dx I'm going to write du upon cos x e to the power sin. I'm copying this whole thing. Okay, e to the power sin x is actually u, so I'm writing u here. This whole thing cancels out with this, so you have to integrate one only, which is going to give you u plus c. And what was u? E to the power sin x plus c. Okay. Okay, let me do one out of these as well. I will take cos x as u equals to cos x. Du upon dx is going to be sin x, negative sin x. Dx is going to be du upon negative sin x. Okay. I can write tan x as sin x upon cos x divided by cos square x. So, okay, dot dx is du upon negative sin x. Okay, let's simplify this first. Integration of sin x upon cos x multiplied by 1 upon cos x, cos square x, dot du upon negative sin x. This and this is going to cancel out. In place of du, I'm going to write down, let me simplify this. It's 1 upon cos cube x. And cos cube x can be taken as u cube dot du. Okay, if you have to differentiate, integrate this, I can take it like this. And then I'm going to start with the integration process. U negative 3 plus 1 is negative 2 upon negative 2 plus c. So the answer here is minus 1 upon 2 u square plus c. What was u is actually cos of x. So it will be cos square x plus c. This is the final answer. Okay. Moving on to question number 3. Evaluate the following definite integrals by using suitable substitutions. Okay. So if I'm doing the first part, I can take 2x minus pi by 2 as u. U equals to 2x minus pi by 2. Okay, this is with practice that you'll get to know. As soon as you see the question, you'll be able to understand what should you take as u and what substitution should you use. Okay, u dash is going, du upon dx is going to be 2. So dx is du upon 2. Okay, so I'm writing cos of u dot, in place of dx I'm writing du upon 2. So 1 upon 2 I'm taking out as constant. I'm supposed to differentiate cos of u now. Integrate cos of u. Integration of cos u is sin u. So half sin of u plus c. Okay. Now, not plus c because I have to apply the boundaries now. So half sin of u, and I am interested in putting the boundaries with x only, so I'm substituting u by 2x minus 2x minus pi by 2. Now you've got two options here at this point. Either you replace u by 2x minus pi by 2, u by 2x minus pi by 2, and put the boundaries. Okay, so that's what I'm doing first. So half sine of 2x minus pi by 2, and I'm going to put the boundaries. The boundaries are pi by 2 and 0 in this case. I'm putting the half I'm taking out as common. I'm putting the boundaries on this. So half outside sine of 2 pi by 2 minus pi by 2. So minus sine of 0 minus pi by 2. Okay, let's solve this bracket. Half sine of pi minus pi by 2 is pi by 2 minus sine of okay, minus sine of 0 minus pi by 2. Sine of negative pi by 2, sine of negative pi by 2. If I just look at the graph of sine, this is pi by 2. Sine of pi by 2. Sine of negative pi by 2 is going to be negative 1. Okay, so minus, I'm just writing sine of pi by 2 here, and then I'm going to do it in the next step. I'm writing sine of negative pi by 2, the bracket closed, half sine of pi by 2 is 1 minus sine of negative pi by 2 is negative 1. Okay, 1 upon 2, 1 plus 1 is 2, so the answer is a 1. This is the final answer. Okay, 1 is the answer. Or if you don't want to revert back to x and you want to use the boundaries for u only, okay, so that also we can do. Now how do we go about doing that way? We know u is actually 2x minus pi by 2, and the boundaries we know are of x, which are pi by 2 and 0. Okay, so in place of x, if I put pi by 2, I'll be left with pi minus pi by 2, which is pi by 2. That means u is going to be pi by 2. And if I take x as 0, okay, so it's going to be u equals to negative pi by 2. Okay, so if you want to instead of putting in place of u, instead of putting this, you can even use apply the boundaries of half sine of u. Half sine of u, the boundaries which you will have to take will be pi by 2 and negative pi by 2. Half sine of pi by 2. Okay, if I take out half as constant outside, that will make things really easier. Sine of pi by 2 minus sine of negative pi by 2. Okay, half sine of pi by 2 is 1 minus sine of negative pi by 2 is negative 1. So half into 2, which is also 1. So either you apply the boundaries for x, okay, or on of u, you will get exactly the same answer. Moving on to if I take this question, now I know that if I'm going to differentiate this, it will become e tan x into sec square x, and there is a possibility that that can cancel out somewhere with this. So that's why I'm taking u equals to e to the power tan x. So du upon dx is going to be e to the power tan x, and differentiation of tan x is sec square x. Okay, so that means if I make dx the subject, it will be du upon sec square x tan x. Okay, so let's do it here. E to the power tan x, okay, upon cos square x. In place of dx, I'm writing du upon sec square x e to the power tan x. Okay, this can cancel out with this. Okay, I'm left, and 1 upon sec square x is cos square x. So it's 1 upon cos square x into cos square x dot du. This is also cancelling out. So the integration of 1 is going to be u only. U plus, don't need to put the boundaries now. So it's going to be u only, and the boundaries are pi by. Okay, in place of u, I'm replacing u with e to the power 10x. That means the answer for integration is e to the power 10x. On this, I can put the boundaries of pi by 4 and 0. E to the power tan of pi by 4 minus e to the power tan of 0. E to the power tan of pi by 4 is 1 minus e to the power tan of 0 is 0 only. E to the power 0. So e to the power 1 minus 1 is going to be the final answer to this question. This is question number 4. Okay, let's do the last one. Question number 5. Okay, in this, if I know that the differential of 1 plus 10x will be sec square x, and that can cancel out with this. So once again, I'm taking the substitution as u equals to 1 plus tan x. Du upon dx is going to be sec square x. Okay, so dx is du upon sec square x. Okay, so what I'm doing is writing 1 upon cos square x into u dot dx is actually du upon sec square x. Okay, 1 upon sec square x is cos square x. This will go up and become cos square x. So 1 upon cos square x u equals to du into cos square x. This and this will cancel out. Okay, leaving integration of 1 upon u dot du, which is ln u. Okay, and u we know is 1 plus tan x. Okay, and now you can put the boundaries of pi by 4 and 0. Okay, ln 1 plus tan of pi by 4 minus ln 1 plus tan of 0. Okay, ln 1 plus tan of pi by 4. Tan of pi by 4 is 1 only. So 1 plus 1 is 2. Minus ln 1 plus tan of 0 is 0 only. Okay, so ln 2, and we know ln 1 is a 0. So ln 2 is the final answer to this question. Okay. Use the substitution x equals to tan theta to show that 1 minus x square upon 1 plus x square the whole square is equals to this. Okay, let's try this now. In place of x, you have to use tan theta. Okay, x equals to tan theta. So dx upon d theta equals to sec square theta. Okay, so dx is going to be sec square theta, sec square x. Sorry, it's a theta, yeah. Sec square theta into d theta. Okay, 1 minus x is tan theta, so tan theta square upon 1 plus tan square theta the whole square dot dx. In place of dx, I can write sec square theta dot d theta. Okay. Okay, this has become 1 minus tan square theta upon 1 plus tan square theta we know is sec square theta into square. So it's sec square theta here. Okay. This sec square theta and this sec square theta will cancel out, leaving sec square theta in the denominator. 1 minus tan square theta upon sec square theta. Okay. And we know the identity. 1 plus tan square theta equals to sec square theta. So in place of tan square theta, we can write sec square theta minus 1. Okay, tan square theta equals to sec square theta minus 1. So we can write this as 1 minus sec square theta minus 1 upon sec square theta dot d theta. Okay, so it's 1 minus sec square theta plus 1 upon sec square theta dot d theta. It's 2 minus sec square theta upon sec square theta. You have to integrate this. Okay, if I put sec square theta in the denominator of both of them separately, I have got this. 2 upon sec square theta can be written as 2 into cos square theta minus 1 dot d theta. Okay, we know 2 cos square theta. We have the identity, double angle identity, which is cos of 2 theta equals to 2 cos square theta minus 1. So in place of 2 cos square theta, I can write cos of 2 theta. Now I'm going to start with the integration process. Cos of 2 theta is the same as sine of 2 theta divided by 2. Okay, plus c. Okay, they had asked us to show this, so we already shown it. Hence, find the value of this. Now, we know this is exactly the same as cos of 2 theta, so we can integrate cos 2 theta and put the boundaries of 1 and 0 for the second part. Okay, so for the second part, this is the first part shown, proved. Okay, for the second part, you have to integrate, which I have already integrated it, and I have to put the boundaries of 1 and 0 on this. Okay, but these are the boundaries for x, so we have to revert to, we have to change it, or what we can do is, in place of theta, we can put the value of theta, which is x is tan theta. Okay, just okay, if I use this here, x equals to tan of theta, and they've given the boundaries for x as 1 and 0. 1 equals to tan theta, so theta is going to be pi by 4, and 0 equals to tan theta, so theta is going to be 0. So you can put the boundaries of pi by 4 and 0 on this. Half sine of 2 pi by 4 minus sine of 2 into 0. Okay, half sine of pi by 2 minus sine of 0. Sine of pi by 2 is 1 minus sine of 0, 0. So half is the answer. Okay.